A lens having focal length f and aperture of diameter d forms an image of intensity I. Aperture of diameter d by 2 in central region of lens is covered by a black paper. Focal length of lens and intensity of image now will respectively be, we have to find out what it is. This is a relatively simple problem where we are basically told that the focal length of the lens is f. So if we have this lens and parallel light rays are approaching it, then they would all merge at this common point, which is at a distance f from the lens. Now we are saying that aperture of diameter d by 2 in central region of the lens is covered. So we are just covering this much portion of the lens. So that much light would not be able to form an image. We can clearly see that the rest of the light that is coming through would still meet at that point, and therefore the focal length would remain the same. So from the options, option B and D are out. And what is the intensity of the image? Intensity of the image is directly proportional to the amount of light that is coming into the lens. If we have blocked aperture of diameter d by 2, the initial area was, let's say, A initial was pi d square by 4, and the final aperture or area, the final area would be the total area pi d square by 4 minus the part of it which is covered, that is pi by 4 into d by 2 whole square, which is simply 3 by 4 into pi d square by 4, and hence the aperture area has been reduced to 75% of the original aperture area. So the intensity would be 75% of the original intensity, and hence option C is the correct answer.